And in circles, this is the inscribed angles. So obviously inscribed means it's going to be inside of the circle. If you look at the picture up there, you see that they have some vocabulary that you should know. A major arc is, we're talking about the outside of the circle right now with the arcs. A major arc is an arc of the circle that measures more than or equal to 180. So a major arc means it's more than half of the circle. A minor arc is less than half of the circle. So that should be kind of self-explanatory. Major arcs can be more than half. Minor arcs can be less than half. A semicircle is that arc that is half of the circle. It's exactly 180. Okay, so again, major and minor should make sense because major is above 180 and minor is below 180. A central angle is an angle formed in the center of the circle. So notice this point is the center of the circle. So that is called a central angle. And the central angle theorem says if this angle is in the center and we know the arc, we also know the angle. So the angle and the arc are exactly the same. They're both 80 degrees in that one. So they are identical or congruent. So in example 1, all it asks us to do here in example 1 is to identify these things that are already on the circle. So let's look at that. The first thing that we want to identify is a semicircle. And to do that, we can go in any direction, but you want to go, it's going to be 180 degrees. So from S to Q, but you also want to tell how you got there. So it's S, T, Q. That would be a semicircle. S, T, Q. And an arc, anytime you say an arc, you draw that little arc above the letters. Okay, a minor arc is one that is less than 180. There's a lot of choices here, but we'll pick the most minor. That would be SR. Okay, that's a very small arc there from S to R. A major arc is one that is more than 180. So let's think about that. If we want to go more than 180, we could start here because we know STQ is 180. So what if we did R to T to Q? That would be more than 180. So that would be a major arc. And you only have to put 3 letters there instead of 4. So you don't have to put R, S, T, Q.
But couldn't there be like other?
Yeah, you could say T, R, Q, I guess, if you wanted to. That would be another major arc. Yep. RQT would be another major arc. So major arcs just have to be more than 180 degrees. That means they go around more than half of the circle. And now, again, it says identify S to T. What would be the degrees of that arc, S to T? It's 86. It's the same as the central angle. STQ. Now, in this case, you know that this is 180 degrees because it's a semicircle. So from S to T to Q, that's your answer, 180. Okay, you could have found this if you wanted to, because if this is 86, this is 94, and this is 145, right? And that means this RT, we'll get that in a minute. If that's 145, then this is 35. So now you've got all the way around your circle. Again, we're piecing together things when we do this. So R to T is going to be 35. You start here, R, you end at T. It's going to be 35 plus 86. So that gives me 121 degrees is the arc from R to T. So as you go through those, you're just kind of piecing together what you know. The central angles have to equal the arc that they go with. So the arc and the central angles are equal with each other. And that's the big key that we're doing today. All right, in the first section, that's example 1. Now we're going to get angles that are not central angles. We're going to get angles where they're not in the center. So in this second part, it says an inscribed angle is an angle that has its vertex on the circle. So not in the center. Its vertex is on the circle. And it's formed by two intersecting chords. That's just two lines there. The inscribed angle theorem is it says the measure of an inscribed angle is half of the intercepted arc. So you have to understand what it means to be the intercepted arc. So in example 2, this angle right here, PQT, this angle is 60 degrees. So I can kind of draw it if you want to see it. PQT. That angle is 60 degrees. Its intercepted arc is where, when I draw that angle, it's where it goes to across the circle. So its intercepted arc, the angle is half the measure of the intercepted arc. So if the angle is 60, what is this arc? 120. Yeah, because the angle is half of the intercepted arc. So if we know that angle is 60, we know that the entire arc there is 120. Now we're going to piece together. So that's A. So A is 120 degrees. Now look at B. Here's angle B. It goes up here and it goes over here. So the arc for B, if you look at its intercepted arc, it goes from here all the way to here. So what's the measure of the arc for B, for angle B? The arc. Here's angle B. Here to here. So how big is the arc for angle B? 150. So for B, it has to be half of the intercepted arc. So 150 degrees divided by 2 means that angle B is 75 degrees. And so now we have angle B. So again, you just have to be careful of looking at the intercepted arc. Just means the two lines, how much of the circle do they cover there on the outside. So on this one, we have all the arcs on the outside. So when we try to find the measure of angle A, measure of angle B, measure of angle C, and the measure of angle D, you have all the arcs. So you want to look at the angle and just add up where the intercepted arc is. So I'm going to give you a chance to try. Angle A, it covers 190 degrees. So what's the measure of A? 95 degrees, right? So it's half of 100 plus 90, so half of 190. So then we can erase that and we can say, all right, angle B goes here to here, so it covers the 64 and 90. So what's the measure of angle B? Anybody?
77.
Yep, 77 degrees. So half of 64 plus 90, so that's half of 154. That'll give me 77. So then we could go to the measure of angle C, which is half of 106 plus 64. It's half of 170. So that is what? 85 degrees. And then finally, we can go to the measure of angle D, which is half of 106 and 100. So half of 206 is 103. Now, also, if you look at this, this is what type of shape inside of the circle that we just did in the unit before? Well, it's just a quadrilateral. So it's a four-sided shape. It may be a trapezoid, probably not. I don't think they're parallel, but they could be, possibly. So it is a quadrilateral, which means that the four angles inside of a quadrilateral have to add up to 360. So if you look at your angles there, they do actually, A, B, C, and D do add up to 360. So that's another way to kind of check your work on that one, is that it's quadrilateral, so they've got to add up to 360. Also, all the way around the circle, all your arcs have to add up to 360, and they do as well as you go through that. Drew angle A, it would go here and here, and angle B would also go here and here. So they would stop at the same points, which means they have the same intercepted arc, which means they've got to be the same measure. So the two angles are the same. An angle that goes to a semicircle is a right angle. So if its arc is 180, the angle is half of 180, that's 90, that means it's a right angle. So if its arc is a semicircle, then it's a right angle. And then it says opposite angles of a quadrilateral are supplementary. So actually, if we would have known one of them, we should have been able to get the other one because they have to add up to 180. So like D and B together should give you 180, right? That would be opposite angles of a quadrilateral or supplementary, and that's true in general, even when we talk about quadrilateral. So we're using that's why circles comes after the quadrilaterals unit, because it's all kind of pieced together. All right, example 3. What's the measure of the numbered angle? First of all, these are your pieces of the puzzle like we talked about. This here is a semicircle, right? So how much is this arc that's up here that's not measured? 140. Because that's 40 and 140, that's 180. If this is 70, how much is this down here? 110. Now we have all the arcs. A lot of times I like to do that first just so I have it. Now look at angle 1. Angle 1 goes to here and to here. It matches corollary 2, which means it's a right angle. So the measure of angle 1 has got to be 90 degrees because it goes to the semicircle. Okay. In this one, notice we know this angle right here is 38 degrees. If we know that angle is 38, then we know that this arc is 76. So I'm just putting that there just to have it. Okay. Now, if we know that angle is 38, look at angle 2 up here. It matches the exact same spots, even though they're opposite, even though they're far away from each other. They both hit the same arcs. So 38 and angle 2 hit the same arcs. So that matches corollary number 1, which says if they hit the same arcs, they have to be equal. So the measure of angle 2 also has to be 38 degrees. So if the two sides of the angle hits the same arc, just like the angle you already have, then they've got to be equal. They've got to be equal. All right. So those on page 2, we want the measure of angle 1, angle 2, angle 3, and angle 4. So can we fill in the arcs first? Sometimes that helps. What would this arc need to be up here? 120. And what about down here? 100. So I think that helps. So the measure of angle 1 goes to here and to here. It's to a semicircle, right? So the measure of angle 1 is how much?
180.
Well, it goes to 180. So what's the measure of the angle? 180 divided by 2. 90. Yep. So the measure of angle 1 is 90 degrees. Its arc is 180, so the angle is 90. Now, measure of angle 3, what is it? Also 90. Now, it's 90 because why? Because it hits the semicircle. That makes it 90, right? Because it hits the semicircle. But it's also 90 because why? One of the corollaries. The opposite angles are supplementary. So if that one's 90, you know the other one's 90. So there's two reasons. It's because it's a right angle, but it's also because of the corollaries. Now, angle 2, look at angle 2. So it's here. So it goes up, you can mark it on your paper, and it goes down. So how much does it cover on the arc? How much does it cover on the arc? 220, so what's the angle?
110.
110. Now, if angle 2 is 110, we don't even have to look at the other one. We can see angle 4 goes to 140, but we don't even have to look at it. We know these are supplementary, so this one has to be 70. Now, you can always check it just to make sure, but you don't have to, right? You don't have to check it just to make sure. So you've got angle 1, 2, 3, and 4, and those are done. Okay? Does that make sense? I think it should. So a tangent chord angle, it says an angle formed by an intersecting tangent line and chord has a vertex on the circle. And the theorem is that the tangent chord's angle is half of the intercepted arc, which is very similar to what we've been doing, where it's half of the arc. So if we look at this, it gives us enough information to piece this together. First of all, PMQ, that arc, PMQ is 212. So all the way around, they have to have given us some information or we wouldn't have a clue what to do, is 212. So P to Q, this other part, this other arc has to be how much? If that part is 212, how much does this have to be?
148.
Yeah, it's the other part from 360. So we now have our arcs, which is very important. So now we have P to Q to R. So there's the angle, P to Q to R. And what arc does it follow? It follows the 148, right? That's where the angle opens. So all they're saying is the measure of angle PQR is just going to be 148 divided by 2, just like we've been doing, which is 74 degrees. Okay? So even though it doesn't like hit it, even though it looks like it's outside a little bit, it's still, what arc does it go to? If they wanted the angle PQS, it would go to 212, so it would be 106. That would be that angle. Okay? Now, and then the last one, KJ is tangent to circle 0. What are the values of X and Y? So first of all, this angle is 35. So, and it goes here and here, so there's a lot of mess here. But that means that this arc here is what? If that angle is 35, this arc is not 90. 70. This arc is 70. I like to kind of work backwards here. Notice this angle here hits at a semicircle, so this arc is 180, and then that would mean the remaining arc is 110. So I've got all my arcs. Okay, it's not what it's asking me for, but it's nice to have. Now, Y is the angle down here. That's Y. So Y goes from here to here. A lot of drawing on there. So Y hits the arc of 110. So what is the measure of angle Y? If it hits the arc at 110 degrees, then it's a 55 degree angle. Now, angle Y is a 55 degree angle. So this one's 55. This one was 90. Now, but they're looking for this little one right here. So it would go here and here. And it would hit this arc, that 70 arc that we made. So angle X is going to be 70 over 2, which is 35. Right? So again, sometimes you got to just kind of be a little careful with how you draw it, but it's all about what arc or what part of the circle does the angle hit. Okay, when you make the angle, you can see what part of the circle that angle hits. So if you'll take a look at some of these practice ones, I'm gonna let you try for just a little bit, and then we'll go back and we'll go over them. Okay, so see how many of these you can get, because these are kind of similar to the questions you're going to be asked in just a few minutes on the classwork. Number 1, we have 82 and 60. So if we subtract from 360, we can get this arc. What is the arc here for A? 218. Yeah, 218 degrees. So then B, the angle B is going to be half of that arc. So angle B has to be 109 degrees. Okay. Angle A has to be half of the arc. So that was an easy one, where A is just 58 degrees. If this is a 90 degree, it's going to have to be a semicircle. If it's a semicircle, then we know we've got a 180 degree arc. Okay. Here, let's look at, I'm going to go back to this one in a second. This is a quadrilateral. Remember, in a quadrilateral, opposite angles are supplementary. So if you know that that one's 68 for A, you can do 180 minus 68 to give you 112. So you know that angle is 112. If you know that angle is 112, then it should hit an arc of 224. Well, if that's 104 and it needs to be 224, then you can find B. And then for C, you have 104 and 120 as your arcs. Another way to get C is, you know that this angle is 71. So if this is 71, you know that its arc, which is all the way across, has to be 142. This is 104. So 142 minus 104 would give you 38. So that's kind of the pieces of the puzzle there as you go through and get those arcs. And then in number 6, it's just showing you that they share the same arc, right? So X and angle Y would share that 72 degree arc. So what's the measure of their angles?
36.
Yeah, they're both 36 degrees. Okay, which leaves us with this last one. This is a central angle. We don't get many of those, but that's a central angle. So if it's 108, actually means that this whole arc is 108. So that's good to know. If we know 156 is this arc and 108 is this arc, then we can find the missing arc. So the outside, I like to get the outside first if I can. So 156 and 108 is 264, and you're going to subtract that from 360. So you get 96 degrees for C. C is 96 degrees. Now, we need to get A, B, and D. Well, A is just the 96 degree arc, so it's just half of that. So if C is 96 degrees, A is 96 divided by 2, which is 48 degrees. So we got that one. D is just half of that 108 degree arc. So D is 108 over 2, which gives us that 54 degree angle. And then B is just going to be half of the 156 degree arc. So B is 156 over 2, which is 78 degrees. So again, there's nothing like extremely difficult in the numbers or anything about it. You got to get the arcs. Once you get the arcs, you can get the angles. Once you get the angles, you make sure that they match up the arcs, that it's divided by 2, and everything should work out perfectly as you go through the process of the intercepted arc. So what you're going to do now is go to the 9 questions for the work for today. Again, work on those 9, put the number answer in. If you miss one, then it will tell you that you missed it, and then you can ask me a question if you need to, and then you can go back second time and make sure you get it right. So check those on Canvas. Those are going to be the ones you turn in for your classwork, and you can turn in these notes now too on there now that you're done.